Assalamualaikum warahmatullahi wabarakatuh. Our topic is basic logging and petrophysical concept presented by Group 1. Consists of 5 people: Muhammad Farhan Lutfillah bin Kamaruddin, that is me, Muhammad Amal Sidqi bin Muhamad Rosli, Muhammad Hifni Afzan bin Harun, Muhammad Faris bin Raffizal, and Muhammad Imran bin Syukri. I will explain about introduction. In the introduction, this is basic logging and petrophysical concept. In basic logging, a process to determine the properties of the geological formation surrounding the bore. In this topic, we learn about the log classification with the log that classify according to the technology that use. We also learn about the type of logs: lithological logs, and electrical logs, porosity logs, and nuclear logs. We emphasize in lithological logs. Lithological logs consist of gamma ray and spontaneous potential, whereby the petrophysical concept is to study of the physical and chemical properties of the rock and their contained fluid. The reservoir is formed of one subsurface of formation containing liquid or gas hydrocarbon of sedimentary origin. Reservoir rock is porous, permeable, and bounded by impermeable barrier, which is trapped hydrocarbon. Porosity and permeability of rock is important to determine which rock will make a good reservoir. In petrophysical concept, it's more by theory, and basic logging is more like a practical, more in practical. That's all for me. Thank you.
Hi, my name is Muhammad Amal. I will be presenting about porosity and permeability concepts and classification. A reservoir rock is a subsurface volume of rock that has sufficient porosity and permeability to permit migration and accumulation of petroleum under adequate trap conditions. Porosity or void fraction is a measure of the void space in a reservoir rock. It is usually reported either as fraction or in a percentage. Porosity is the property that tells how porous a rock. It also can be defined as a measure of capacity of reservoir rock to contain or store fluid. The porosity is genetically classified based on standard sedimentology description of reservoir rock. High porosity value indicate high capacity of the reservoir rock to contain fluids, while low porosity value indicate the opposite. Porosity can be classified into two types, which are primary porosity and secondary porosity. First, primary porosity describes the pore space between grains that are formed during depositional processes such as sedimentation and diagenesis. Meanwhile, secondary porosity is formed from post-depositional process such as dissolution, precipitation, and fracturing. Total porosity is the sum of the primary and secondary porosities. Permeability is a measure of ability of fluids to pass through its porous medium. It is also a property of rock and is independent of the fluid. Permeability can be divided into three types, which are absolute permeability, effective permeability, and relative permeability. The first is absolute permeability. It is an ability to flow fluids through a permeable rock when only one type of fluid is in the rock pore spaces. When the medium is completely saturated with one fluid, then the permeability measurement is often referred to as absolute permeability. Effective permeability is occurred when the rock's pore space contains more than one fluid. It is the ability to advantageously transmit a particular fluid when there are other immiscible fluids in a reservoir. Relative permeability is the ratio of effective permeability of a particular fluid at a particular saturation to absolute permeability of that fluid at total saturation. Permeability is one of important factor to determine the effective reservoir. In a petroleum reservoir, the rock is usually not fully saturated with a single phase fluid. Generally, saturation in the reservoir rock will consist of different amount of gas, oil, and water. These saturations will change the effective permeability of the rock. Reservoir is a subsurface body of rock having sufficient porosity and permeability to store and transmit fluid. This reservoir rock may or may not be the rock in which the hydrocarbon was generated from its source rock. There are three conditions must be present for oil reservoir to form. First is a source rock that is rich in hydrocarbon material buried deep enough for subterranean heat to cook it into oil. Source rock is defined as the fine-grained sediment with sufficient amount of organic matter, which can generate and release enough hydrocarbons to form a commercial accumulation of oil or gas. Next is porous and permeable reservoir rock for oil to accumulate. Porosity and permeability are the reservoir rock most significant physical properties. Moreover, a reservoir rock can be porous without being permeable. Porosity and permeability are related properties of any rock or loose sediments. And the last one is cap rock or seal that prevent oil from escaping to the surface, also needed in order to produce an oil reservoir. Cap rock is a harder or more resistant rock type overlying a weaker or less resistant rock type. In the petroleum industry, cap rock is any non-permeable formation that may trap oil, gas or water, which preventing it from migrating to the surface. This cap rock or trap can create a reservoir of oil, gas or water beneath it and is a primary target for the petroleum industry for oil production. Let's move on to the next presenter.
Assalamualaikum and hi everyone, my name is Hifni Afzan and I would like to present to all of you an introduction to well logging. So without further ado, let me give a little bit explanation on term of definition of well logging. Well logging is also known as bare hole logging. It is technique for determine the physical and chemical quality of the rocks and the fluid they contain by taking petrophysical observation in subsurface earth formations. The formation and any occurrence is observed throughout the drilling operations and recorded in well logs. It is basically inform the engineer what they are going to go as it go further and further down the hole. So the figure shown here is one of the example of well log reports. Did you know that after a well has been drilled, it is required to determine the well hydrocarbon potentiality in relation to the reservoir, because the hydrocarbon potentiality only can be determined by analysis the subsurface petrophysical data. As all of you can see here, the mind map show the petrophysical property of rocks. Well logging are used as it's less expensive and way more faster to gather reliable subsurface petrophysical data. Next, the mind map here show the well logging data flow. The measurement from the well logging are important to determine the well hydrocarbons potential, determine the type and volume of hydrocarbons, determine the sort of fluid that will flow and the pace at which they will flow, and lastly to optimizing the well construction and hydrocarbon outputs. Meanwhile, the purpose of well logging is to find the hydrocarbon reservoir characteristics, define the total and recoverable reservoir, and lastly to produce from a certain reservoir. Let's move on to the next part. Log classification according to the major property. This picture here show the basic well logging operations. As well logging technology has advanced over the year, a variety of well log have arisen. Depending on the location, either onshore or offshore, and the needs of logging operations, many logging service companies use a variety logging units. The whole process involving quite number of electronic technology and provide critical information for lithologists and mineral grades. Well logging can be classified based on technology they use and based on their functions. As I mentioned before, well logging measurements are carried out through the drill borehole. Based on the technology used, the measurements are recorded in either an open hole or cassette hole logs. For open hole logs, the operations are performed in the formation, while for the cassette hole logs, the operation performed rarely but still provide important information of the well. Open hole logs are the most type of well loggings used in the industry because of the basic petrophysical measurement for the formation evolution are recorded. On the other hand, cassette hall logs, the measurement mostly concerned with development and productions are recorded in the cassette hall logs, and it help the operator to gain more information about the reservoir. So for classification of well log according to their functions, property or reservoir characteristic, there are various type of well logging have been developed over the time to collect all the data about the wellbore and subsurface informations. Lithology logs, electrical logs, porosity logs, nuclear logging, and corrosion logs are the most known well logging in the industry. Then each of them can be subdivided into smaller parts. My friends will be explaining a little bit deep some of these logging types. So that's all from me. Thank you for your kind attention. Now I am happy to pass the presentation to the next presenter. Thank you.
Now I'm going to continue our presentation with the next part, which is auxiliary measurements, uses and common issues. So the first one is caliper log. So caliper logs are the first run in a borehole that determine the diameter of the hole or casing. Caliper logs serve as a supplement to other metrics such as environmental adjustment and cement volume calculations. Caliper logs can also be used to identify poor hole situations. Caliper measurements can be performed in both open and case wells with any borehole liquid. Caliper instruments with 1 arm, 2 arm or 3 arms are used to measure the borehole diameter. The movement is turned into an electrical signal via a potentiometer. The more the arms, the more precise the measurement of the well bore shape and the cross-sectional area. So most density and micro-resistivity instruments include 1-arm calipers. The mechanical caliper device, or MCD in short, is a 3-arm caliper tool. So the next measurement is temperature log. So the temperature log of borehole fluids is measured using a temperature log. Temperature logging is also used to detect variations in the thermal conductivity of the rocks along the borehole, as well as the water movement through cracks and fractures. This is due to the fact the temperature at the bottom of the well will be the highest. Temperature data can be used to compensate for other logging tool sensors being temperature sensitive. This is because some of characteristics assessed by tools are temperature sensitive and measurement must be correct. Temperature log measurement has a few applications, including correction of other tools management. The temperature log can also be used to create correlation in the maturation of hydrocarbons. The highest temperature to which the organic residues have been exposed throughout time and pressure determine the maturity of hydrocarbons. Correlation can also be done with a temperature log. So last but not least is a deep meter log. So the deep meter log keeps track of the depth and azimuth of a formation. Depths are measured with regard to the borehole or with the geographic north and the earth's vertical at a particular location or true depths. Deep meter measurements are used to determine structural depths in the strata traversed by the borehole. This may be done monitoring changes in electrical characteristics of the rocks along the wall's tracks. The results of deep meters can be indicate faults, unconformities, or important depositional trends. There are few typical difficulties when using a deep meter to measure anything. The deep meter log interpretation is based on the premise that some beds, often low energy deposits, were formed horizontally. Salt domes, on the other hand, are frequently formed at structural discontinuities. That's all for me. Next presenter, please continue.
Assalamualaikum and selamat sejahtera. My name is Muhamad Faris and I'm going to talk about the basic measurement, gamma ray and spontaneous potential. Firstly is gamma ray. Gamma ray degrade the natural radioactive information and may be used for figuring out lithologies and for correlating zone. For shallow sandstone and carbonate that have low concentration of radioactive material and supply low gamma ray readings. So when shell content material increase, the gamma ray log reaction will increase due to the concentration of radioactive in the material shell. The next is gamma ray log tools. First is simple gamma ray. It is for supply gamma ray and it is made from scintillation counter and photo multiplier tube. The scintillation counter is normally a crystal of sodium iodide which produce a flash of mild light whilst bombarded with gamma rays. The flash of light is detected by the photo multiplier tube and transformed into electrical power sign. Then it is in the API unit. Okay, next is spectral gamma ray. It is also made from scintillating counter and photomultiplier. But the photomultiplier additionally notes the depth of the mile produced. It has a bigger sensitivity because scintillating counter use is way bigger. Okay, next is for spontaneous potential. Okay, the spontaneous potential curve is a non-stop recording versus depth of the electrical ability distinction among a movable electrode in the borehole and the surface of the electrode. SP reading normally outlines a directly line referred to as the shell baseline. Okay, for permeable formations, the curve depart from the shell baseline in thick permeable beds. Those two attend a consistent departure from the shell baseline. Next is the static spontaneous potential SSP. It is flow via 4 unique media, which is borehole fluid, invaded zone, uninvaded part of the permeable formation, and surrounding shells. So SSP is decided by a sand line is drawn through the maximum, normally negative excursion of the SP curve, joining to the thickest permeable beds. A shell baseline is drawn through the SP through the intervening shell beds. Finally, the separation of the sand line from the shell baseline measured in MV is the SSP. Okay, I think that's all from me. Thank you.
Hi again. I will explain about the conclusion. In the conclusion, this project bind together our concept that we have learned in the lecture, and we learn about the introduction of the well drilling, learn about introduction of the logs classification, which is there's several logs that under lithological. There is gamma ray and spontaneous potential. Learn about the use and common issue of auxiliary measurement. We learn about the minimum condition for productivity of the reservoir, and the porosity and permeability of rock is important to determine which rock will make a good reservoir. That's all for me. Thank you.